Welcome to the Copperfield Electric Podcast. Today, we're diving deep into something a lot of homeowners think about: wiring a detached garage the right way. If you're tired of tripping over extension cords or maybe just hoping that old shed light lasts another season. Well, our mission here is to walk you through how the pros tackle this, how to build a system that's safe, up to code, and ready for the future, moving beyond just basic power to really create a useful workspace.
That's right. We've pulled together information that covers, well, both the really strict code requirements and the practical steps licensed installers take. We're basically laying out the roadmap you need. And we're focusing heavily on that initial planning because cutting corners here, it just causes problems later. It's not just about pulling wire.
Yeah.
It's really about designing the whole system properly.
Yeah, exactly. And our goal for you listening in isn't just to know the steps, but to really get the why. Like, why are things like subpanels and conduits so important, often non-negotiable? And how thinking about the long term now actually saves you a ton of money and risk down the road.
Right. And just to set the stage, we're looking at the kind of standards set by companies who do this complex residential work all the time, like Copperfield Electric. Because for a job like this, running power underground to a separate building, you need solid guarantees. We're talking licensed. Their number is #1094740 bonded insured professionals. That's really the baseline credential you need when you're dealing with major electrical work.
And their approach, it emphasizes things like background checked electricians, a 100% guarantee on the work, which when you're, messing with your main electrical panel and digging trenches, that peace of mind is pretty valuable.
Absolutely.
We should also mention their service area. They're focused on Southern California, specifically Orange County.
Yeah.
Places like Irvine, Anaheim, Santa Ana, Costa Mesa.
Newport Beach, Laguna Beach, Mission Viejo.
Right. And their services, things like panel upgrades, EV charger installations, they tie directly into this kind of project. Wiring a detached structure often goes hand in hand with those bigger upgrades.
Exactly. I mean, when you plan a project this size, you're really leaning on their expertise in areas like new construction wiring, maybe accessory dwelling units, ADUs, which require pretty much the exact same careful power calculation and code compliance as wiring up a big garage workshop.
Okay, let's unpack that. Let's get straight to really the most crucial part, which has to be the planning. Wiring a detached garage isn't cheap, and yeah, nobody wants to dig that trench twice. So the biggest takeaway seems to be plan for everything you might ever want out there right now.
I like to call it the future-proofing tax.
Yeah.
And honestly, it's the best investment you can possibly make on a project like this. Step one is always assessing your power needs. You absolutely have to list every single device you could imagine using out there. If you skip this or, try to save a few bucks on smaller wire today, that cost is nothing compared to tearing up your yard again later to run bigger feeder lines. It's just not worth it.
Okay, give us some specifics then. On the load assessment, what are the typical things that push a basic garage setup into needing, well, a more serious electrical plan?
Right. So you've got your standard 120-volt stuff, general lighting, and really you should be thinking energy-efficient LEDs there, and your regular wall outlets, of course. But then you have the heavy hitters.
Okay.
Things like power tools, big saws, compressors. They might need their own dedicated 20-amp circuits because they draw a lot of current when they start up.
Right. I've tripped breakers with my shop vac before.
Exactly. And then the really big jumps come with things like climate control or increasingly EV chargers.
Ah, okay. That's the 240-volt stuff.
Correct. Those are high-demand appliances. They need specialized 240-volt circuits. Think like your electric dryer or your oven uses that kind of power. So if you're even thinking about an HVAC unit for heating and cooling or putting in an EV charger, maybe even 5 years from now, you absolutely must size the main wire running for the house to handle that 240-volt load today. Oh, and another tip. We always recommend a dedicated circuit for any fridge or freezer you plan to put out there. Just prevents nuisance strips from other tools potentially spoiling your food.
That's a good point. So, okay, once we have a list and we know how much power we need now and potentially in the future, the next big question is, who makes the rules for how we actually deliver that power safely? Which leads us straight into electrical codes. That seems to be the biggest hurdle for DIY attempts.
Yeah, and compliance, well, it isn't really optional. It's mandated by law to protect you, your property, your neighbors, your investment, really. This is honestly where hiring a licensed electrician really pays off, because local codes dictate a whole host of really crucial safety details. If the work isn't up to code, you risk problems with your insurance, major headaches if you try to sell the house, and, well, the worst case, a serious fire hazard.
So what specifically are we talking about when we say code dictates safety? What kind of rules?
We're talking about the nitty-gritty details that ensure the system won't fail dangerously. Things like the minimum wire gauge, the thickness of the wire for your specific load, and the distance it has to travel. That prevents overheating. Code also dictates the type of conduit you need, that protective pipe, whether it's metal or PVC, and critically, how deep that conduit needs to be buried if you run the wires underground. Plus, rules for GFCI protection on outlet, breaker sizes, labeling. It's comprehensive.
I know people sometimes want to cut corners on that burial depth to save on digging. Seems like a lot of work. What's the actual risk there?
The risk is huge. Seriously. Those wires need to be deep enough, sometimes 18 inches, sometimes 24 inches, depending on the voltage and the conduit type, specifically to protect them. Protect them from what? Future landscaping, someone digging a fence post years later, even just ground settling or frost heave. If that wire gets nicked or crushed because it wasn't deep enough, you could have an immediate short circuit. That means fire risk, electrocution risk. And it might happen underground, far from the house, where you don't even realize there's a problem until it's too late.
Okay, point taken. So digging deep is non-negotiable. Let's talk about getting the power across the yard. Overhead wires seem easier, maybe, but underground is what you usually see.
Underground is definitely preferred these days. It looks cleaner, less chance of damage from weather or falling branches.
Yeah.
But, like we just discussed, it forces you to be really rigorous about that trench depth and using the right conduit.
Right, the protective pipe.
Yeah, conduit, whether it's the rigid metal kind or the heavy-duty PVC type, it's absolutely essential underground. It shields the wires not just from shovels, but also from moisture seeping in over time, even from rodents chewing on things. All that prevents the wire insulation from breaking down, which again leads to failure and fire risk. And look, we have to stress this based on the sources. Never ever rely on an extension cord for permanent power to a detached building. It's just not designed for that. It's a massive fire hazard, and it's absolutely not up to code.
Okay, crystal clear on the extension cords. That brings us to another big question people ask, the subpanel. If I've got a perfectly good breaker box on my house, why would I need a whole separate second panel out in the garage?
The subpanel question. Yeah, it's a really important distinction. Functionally, think of the subpanel like a dedicated electrical brain just for the garage. It takes one large feed of power from your main house panel through those heavy feeder wires we talked about, and then it distributes that power locally within the garage through its own set of breakers. This stops you from having to cram like a dozen new breakers for all the garage circuits into your main house panel, which might already be crowded.
Okay, so it manages the garage circuits locally. What are the actual benefits? Is it worth the extra cost and installation?
Usually, yes. There are three main benefits: control, expansion, and balance. First, control. If a breaker trips, it trips right there in the garage, making it much easier to figure out what went wrong and reset it. Second, and this is huge, expansion. It makes adding circuits later so much easier. Want that EV charger next year? You just add a new breaker to the garage subpanel. Much simpler than running a whole new line back to the house panel. And finally, balance. It just reduces the overall electrical load and, frankly, the physical clutter on your main house panel. Generally, if you think you'll need more than just two basic circuits out there, say one for lights, one for outlets, then a subpanel is really the right way to go for the long term.
Makes sense. So assuming we've got the subpanel plan, the wires are run safely in conduit, then we get to the final details inside the garage, right? Lighting and outlets. This is where you actually make the space usable.
Absolutely. Good visibility is key. You want decent overhead lighting on. LED fixtures are great for energy efficiency and brightness. And definitely plan for task lighting, like dedicated lights right over any workbench area. Makes a huge difference.
And outlets. How many is enough?
The standard recommendation is to install them pretty frequently along the walls, maybe every 6 to 12 feet. Why? It minimizes the need to string extension cords inside the garage, which can be a trip hazard and just messy.
Okay. And we have to circle back to safety here. GFCI protection. You mentioned it earlier with code. Why are GFCI outlets mandatory in a garage, even if it seems pretty dry?
Right. It might seem dry, but garages detached or attached are officially considered damp locations in the electrical code. Think about it. Concrete floors can hold moisture. You might bring in a wet car. Maybe you're washing something.
Yeah.
There's a higher potential for contact with water or grounded surfaces. Ground fault circuit interrupters, GFCIs, are designed to detect tiny imbalances in the current. Like if electricity is going somewhere it shouldn't, maybe through a person, and they shut the power off instantly. Milliseconds. It's a critical life safety feature, so any circuit supplying outlets in the garage needs that GFCI protection, either through GFCI outlets themselves or a GFCI breaker back in the subpanel.
Okay. So, lights planned, Outlets placed frequently, GFCI protection everywhere. Now we get to the final connection, right? Hooking it all up. This sounds like the most dangerous part.
It absolutely is. And this is precisely why professional completion and testing are non-negotiable for almost everyone.
Huh.
The licensed electrician handles that final hazardous connection, usually back at the main panel or connecting the feeder to the new subpanel. Then, they meticulously test every single circuit. They verify the grounding is solid, that's crucial for safety systems to work. They check voltages, make sure every light switch is on, every outlet has power. Basically, they ensure everything works exactly as designed and is completely safe before it gets the final okay, maybe from an inspector. Seriously, unless you have significant electrical experience and qualifications, never attempt to make those final connections yourself. Electricity is incredibly unforgiving. One mistake can be disastrous, even fatal.
Understood. So if we boil it all down, the key pillars for doing this right seem to be that detailed power assessment up front, strict adherence to the electrical code, especially on wire size and burial depth,
Yep.
using protective conduit for all the wiring runs,
Crucial.
and making that informed decision about needing a subpanel, thinking about future use.
Exactly. And if we connect this back to the bigger picture, remember that future-proofing tax we talked about.
Yeah.
Thinking ahead really is key. The most common and honestly the most expensive mistake people make is underestimating what they might want later. That forces them into that costly scenario of digging everything up again.
So what's the single best piece of advice then to avoid that pain of rewiring down the line?
Plan for your biggest potential future need now, even if it feels like overkill today. Is it that high-speed EV charger, a big welder for a workshop, maybe full HVAC because you might turn it into a home gym or office someday? Whatever it is, make sure the main wire gauge you run from the house to the garage today is big enough to handle that future load. And here's a pro tip. Even if you don't install a fully loaded subpanel right away, consider running an extra empty conduit alongside the main power line during that initial trenching.
Ah, like a spare pipe.
Exactly. It makes adding communication cables, or maybe even another electrical circuit later, exponentially cheaper and easier because the pathway's already there. No more digging.
That really is smart planning. Well, it's clear that if your garage dreams involve heavy-duty tools, EV charging, sub-panels, or anything beyond basic lighting, getting professional, licensed help is the surest way to end up with wiring that's safe, code-compliant, and truly ready for whatever you throw at it in the future. Thanks for walking us through all that today.